This 3-minute video is about scientific notation. And scientific notation is simply a way of writing really big or really small numbers. Here's a couple examples for us to think about. In meters, how far is it to the moon? Well, we will see that it's 384 million meters away. That's a big number. How big is a blood cell? Well, a blood cell is 0.00000750 meters. Examples to think about. First of all, the number 12. The number 12 can be written as 1.2 or 1.2 times 10. And if you forget how to do these, maybe go back and review your multiplying and dividing by 10 rules. But that can be written as 1.2 times 10 to the power 1 because we had 110. Well, what about 8,300? Well, 8,300 is 8.3 times 1,000. And 1,000 is just 10 times 10 times 10, which is 10 cubed, or 10 to the power of 3. So 8,300 is 8.3 times 10 to the 3. Likewise, if you're dividing, 0.5 is the same thing as saying 5 divided by 10. Once again, I'm just moving that decimal place over one place to know that it's times 10. And if you're dividing by 10, that's the same as multiplying by 10 to the negative 1. Once again, here I have a small number, 0.00029. And you'll see that I've just gone 1, 2, 3, 4 places over. So it's 2.9 divided by 10,000. Or that's 2.9 divided by 4 tens. So the answer here is 2.9 times 10 to the negative 4. First, but we're going to convert these numbers to scientific notation. So this is 7 times 10, or in proper scientific notation, 7 times 10 to the power of 1. 230 is 2.3 times 100, or 2.3 times 10 to the power of 2. And all we're doing here is just imagine that we have a decimal here that's being moved 2 places to the left. The question before us, one decimal place to the left. I see this, I don't even know what that number is, so I'm going to write it as 8.4 times 10, and I'm going to count my decimal places. And because this is written in good notation here, I know that's 3, 6, 9, 10, 11 places over. This is going to be 6.54502 times 10 to the 1, 2, 3, 4, 5 places over. Similarly, we do this with numbers smaller than 0. So this would be 8 times 10, but this time we're going to move the decimal to the right, which makes it a negative 1 exponent. This number will be 5 times 10 to the 3, 6, 7, 8 places to get it right there. And once again, this will be 5.29, and I'm going to move this 3, 4 places to get it there. And that was to the power of negative 5. And I left my negative out on the previous question. The only rule we need to keep in mind here is that the number that's the base number that's written here must be somewhere 1 to 9 as the base number. Okay? Notation into proper number format. This is just saying 5 times 10, so that's 50. This one is saying 2 times 10 times 10 times 10, which is 2,000. This one is 5.4, and I need to move my decimal place 5 places, and it's going to be a bigger number, so I'm going to move it over here 5 places that way. So it's going to be 540,000. I've got a big number here with the 12, 9, 1, 5. I'm just going to put a bunch of zeros in here. I know there's going to have to be a bunch. How many is that? So once again, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I went a little bit too far. So this one would be 915 with 10 zeros after it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Very good. This one is 6 divided by 10, which is 0.6. This is 7.3 divided by 10 to the fourth. And that's going to be 0 decimal. It's going to be several zeros here. Okay, and what I'm doing is my decimal was here. I'm going to go 4 places. 2, 3, 4. Or my last one here, 8.39251. And what I need to do is I need to move that 11 places to the left. So what I'm going to do, I'll switch colors here. So I'm going to go 11 places to the left. Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it'll be 0 decimal and then a lot of zeros here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I added 1 extra decimal. Lastly, let me show you how to put numbers using scientific notation into our TI calculators. It's really quite simple. You put the base number in. Let's say you have 6.02 and you have an exponent. You're going to go to the second feature, and down here, see it EE here in blue, EE. And you'll see on your screen it says 6.02 e to the power of 23, commonly known as Avogadro's number. And then when you multiply or divide that, so let's say I'm going to multiply that by 1.6 to the second power, your second function e, and to the power of 5, hit enter, and you'll see I've got my numbers written here in scientific notation, 6.02 times 10 to the 23rd multiplied by 1.6 times 10 to the 5th gives me an answer of 9.632 to the power of 10 to the 28.